This program was brought to you by Coller Institute of Venture at Tel Aviv University.
My name is Melo, and I'm going to give you just a brief introduction about marine renewable energies. And my presentation will cover these topics: the global resource, wave energy development, prototypes in the sea, how technology is progressing, cost of demonstration projects, and the goal of WAVEC in this context. The ocean energy can be harnessed by different ways. We have tidal energy associated with the rise and fall of the tide. We can use the energy from oceanic and from tidal currents. We have wave energy. We can also use the energy from salinity gradient, the mixing of fresh water with salty ocean near rivers where much energy is released. And we can also use the thermal gradient associated with the difference in temperature between the warm sea surface and the deep cold water in equatorial waters. I will focus my presentation on wave energy because it's one of the most familiar resources in the ocean, and there is a huge potential. Here you can see the most energetic resource in latitudes between 40 and 60 degrees in the northern and in the southern hemisphere. If we look to the wave energy development, we see that the installed capacity since the 90s has been slowly but steadily growing, this red line, and the small blue points refers to projects during tests, intermittent tests during short periods of time. Several prototypes have been tested in the sea, in several places around the world, in Portugal, New Zealand, USA, Australia, United Kingdom, China, etc. This is a crucial milestone to put a device in the water. There are several wave energy conversion principles. They are widely different in operating modes, but most of all use relative motion, linear or rotational, between parts of the device or between the device and the bottom of the ocean. There are also several power takeoff alternatives: air turbines, water turbines, hydraulic systems, direct drive generators, etc. The number of projects by conversion principle has been growing over these last 10 years. These different colors refer to different types of technologies. So we don't see a convergence to a single concept, as we have seen did happen with other similar sectors, like, for instance, in the wind energy, where we converged to a turbine with 3 blades. How technology is progressing. The evolution of the TRL, the technology readiness level, it gives a clear picture about the progress of the technology. And we see that proof of concept has been happening in these last 10 years. There is a growing amount of technologies reaching TRL 5 and 6, that is demonstrating the devices in the water in part scale with part scale models or in benign areas. So this shows some advance in the maturity of the sector. And there are several companies at TRL 7 struggling to achieve TRL 8, which is the fully demonstration of the performance, operability, and survivability. Looking to the cost of demonstration projects, developers are not so keen on publishing information. This is based on information for installed projects and planned projects that we could collect from different sources. And we see that there is a high unitary cost per megawatt, and the capital costs show much variability among different concepts. In what concerns operational costs, there is no realistic information because there are no devices operating during long periods of time. So, what are the risks impeding development? We see risks, significant risks in three main fronts. There is a technology risk associated with uncertainties on the reliability and survivability and cost reduction potential of wave energy technologies. There is a financial risk associated with the high capital investment, which is behind the reach of most startup business, and lack of long-term revenue support. And there is a regulatory risk associated with the unknown interactions, or in some way related with unknown interactions between the devices and the marine environment, and with potential conflicts of use. So there is a need to de-risk wave energy technology. And in the next years, the ability to reduce these risks will be a decisive factor towards creating a new industrial sector on wave energy. So what is the goal of WaveVec in this context? Is the implementation of an offshore renewable energy industry through technical and strategic support to companies, identification and mitigation of barriers, and cooperation with all relevant stakeholders at these three levels, at the governmental level, research, and industry. Thank you.
This program was brought to you by Coller Institute of Venture at Tel Aviv University.